Wow, look at that. What a gorgeous morning. How y'all doing? So, I was just thinking early, way too early to be up this morning. I was thinking, like, what's a cool thing to talk about? Like, would be a neat thing if I didn't know something, like, would be a neat thing to know. So I was thought about it a lot, probably too much. Oh wow, look at these ants. I see their road. They built a road across my road. It's very neat. Very large ants. But you know, I'm sitting here thinking, like, what would be a cool thing to talk about? Light. Like, light's really cool. I can't think of anything that's like kind of more important on Earth than the light. If you really think about it, you know, everything we owe on this great planet, or in this Tennessee jungle with all sorts of wildlife of all sorts. I got dog hair. If you have dogs, you know that, or is a spider web. I think it was dog hair. But you know, if it wasn't for light, we wouldn't have anything on this planet. It'd just be a barren rock floating through space. You know, light really gives us all that energy. All the energy we find on Earth is actually just a different version of stored energy that's coming from that gorgeous sun up there. So, and that light you see shining down on me, and I see everywhere, that light that's reflecting back to me, showing me that this gravel here is like different tans and hues of blues and grays. And then, well, I'm colorblind, so for me this grass is various shades of oranges. That's just how light reflects back to me. But you know, that light that came down took 8 minutes and 20 seconds to shine from the you know, the sun down here. And then if it wasn't for those photons carrying that energy from the sun, because if you think about it, that sun is a giant molten nuclear reactor that's just sitting there spewing out energy, and it has been, and it will continue to do so for a real long time. And if it wasn't for that energy's what's given us life here on Earth. You know, you think about this clover here in this field. You know, the photons are coming down from that sun. Energy from that sun is being bundled up and delivered, you know, right to those leaves and those, you know, the petals of the flowers and the leaves on those clovers. And then the deer will come in and eat that grass, and then it goes into there. And then one of these horrendous, probably freaking like packs of coyotes that live on this property probably eats one of those deer. Either way, the cycle of life kind of continues. It's just a repackaging and repurposing of that original energy that came from the sun, if you think about it, you know, from the smallest bacteria all the way up to us humans here, you know, most complex species on the planet, I'd argue. You know, it's really just different variations and continuations of those photons and that energy that came from that sunlight up there behind me. 500 seconds. Now, the weird thing is 500 seconds ago, that photon decided if I was going to see it or if I was going to use a device of some kind to measure it. Well, that's weird, but that's how it goes. It's called a quantum wave function collapse. So a long time ago, some scientists, I never went to college, I don't know, but I can't remember their names, but some scientists, they fired some lasers straight through like a piece of paper. They put 2 slits in that paper, and then they looked at, you know, they took like a photoreactive material and lined the back wall with it, and they saw what happened to that. Now, what do I mean by photoreactive material? Think of like glow-in-the-dark stuff. You know, you hold it up to the light, it stores that light energy, you turn the lights out, and all of a sudden, you know, you can see that little star, or, you know, maybe like a cutout of the moon or something, glowing there in the dark. It's kind of the same thing. And so, so they did something like that, and they saw that when they looked at it, well, it's kind of what you would expect. If you had a laser shooting through 2 slits and you're, you know, shooting and it went through one slit or the other, you're going to see a straight line on the other side of that wall, just like you'd expect. Oh, that's pretty normal, because, you know, that's what they expected. But then something funny happened. And what happened is when they didn't look at it. And that's where things got weird. You know, this is where a lot of the stuff in quantum physics and stuff gets really neat and cool. because when they didn't look at it, that photon of light, it didn't just go through one slit. It went through both. Like, for real. It went through both of them. Whoa. So that really changed a lot about how we thought about the world around us, and you know, that with other physicists and scientists and mathematicians, you know, quantum physics is now what it is now and what we understand it to be today. But either way, it was earth-shattering if you really think about it, because what happened is back then, scientists discovered that it literally depends on how you look at it. So, what do I mean by that? Well, imagine this. This clover here in this little field, when it's taking in that sunlight, you know, that photon hits it, it's taking that energy, it's converting it into glucose, you know, and it's drawing up nutrients out from the ground. It's taking that light energy. Well, that's because it was a photon. Now imagine this. Imagine if you used some sort of imaging device, maybe a prism, you know, and you broke that light up and you see Roy G. Biv there, you know, the whole color spectrum sitting there. Well, that's not a photon. That's a wave. That's a wave of light of what you're seeing, because that thing's diffracted. It's all broken up. You know, it's like it's not carrying the energy that a photon does. So it literally depends on how you look at it. Well, what makes that super cool and crazy is how did the sun know 8 minutes ago I was going to look at it? That's really weird. You know, so imagine this. Imagine if we're looking out into the depths of space, okay? And let's say let's say you ate your carrots as a child, like they used to say, and that you can see really, really far. I don't know. Maybe you could be a next X-Man or something like that. You know, maybe like they call you Eagle Eye, something like that. I don't know. It might be a cool power. Who knows? But let's say you can see the star system that ejected the asteroid that killed the dinosaurs, you know, 65 million years ago. Now, I don't know how far away that asteroid system was. I'm sure it probably took maybe another 65 million years. It could have taken 8 billion years ago. We don't know when that star system even exploded. But let's just say, for whatever reason, you're able to see that exact star system, however long ago it was. Let's say, okay, no, you know what? Let's say it was 2 billion years ago, okay? 2 billion years ago, some star somewhere out in space, deep space, place we never heard of, never seen, we'll never go, let's face it, shot out, its star exploded, or a planet collapsed into another one, and it shot out an asteroid. We'll just say it was a star, though, because I need that photon for my example. So let's say you see that star from that planet up in the sky, somehow, for some reason, okay? How did you see it? Well, you saw it because you looked at it. That means that photon, however many years ago, let's say 2 billion years ago, you know, there was a star somewhere out in space with a nuclear reactor going on, and it ejected a photon, and it traveled for 2 billion years through the depths of space and time or whatever to reach your eyeball. And that photon stimulated the optic nerve. And that's how you saw it, because you looked at it, you know. A smaller example that only takes 8 minutes and 20 seconds is to look up at the sun. You want to talk about a photon and see what I talk about when it stimulates your optic nerve? Well, one, it's because you saw it, but two, just stare at the sun for like, not long, like a second, or even a light bulb. Do a light bulb, there you go. It'll work, kids. But I'm sure everybody's done it where they've looked at a light, you close your eyes, and you know, you've walked in from a light room to a dark room, you know, or you've ever been beamed in the eyes with some headlights or something, and you see those headlights like, well, that's because that photon had to stimulate that nerve in your eye to begin with. So you wouldn't have seen it, you know, if that photon hadn't hit your eye. Now again, let's go back to that original premise though. How is it that all those millions or billions or however long years ago, how is it that knew that you were going to look at it? So I would argue therefore then that the conscious observer is really the catalyst. So let's put that into some tangible perspectives here. So light can either be a wave or a photon. It's up to the conscious observer of how they look at it, literally, on how it's going to be. Is it a wave or is it a photon? That's quantum wave function collapse right there. Now, I don't know how that applies to necessarily scientific applications, but it is really cool. And I think it really goes to show that, you know, really the conscious observer is kind of the, you know, it's kind of the belly button for reality itself, because it would appear that light has actually been in itself to the observer. You know, I would argue that probably the reality around us is maybe a gentle lake, and on the surface of that lake is a bunch of realities, and that's us, each of our bubbles of observations, because all we're doing is going around. Every time we look at something, we're collapsing wave functions from somewhere, from some source of energy somewhere. So everything you see is entirely a collapsed wave function of some kind. So I would say that really kind of helps grasp that notion that we are actually creators in this reality. Because if you don't see it, you know, now there is a shared reality, of course, but your bubble will pop one day, you know, all bubbles will pop, you know, that's kind of how things go. But either way, it's really cool, and none of it would be possible without that thing called light. And that's all I wanted to share. So you have a good morning. Hopefully I'll make it back before I get eaten by a coyote. Probably a turkey. Dude, these turkeys are huge. Did you know Tennessee has rattlesnakes? I did not know that. I've spent a lot of time out in Texas, but I was out mowing the bowl down below my property, and I saw a 7-foot, I think it's called a timber rattlesnake. I didn't know they were in Tennessee. However, there are. It was about 7 feet long. It was huge. It was like black and white and gray. I'm colorblind, keep that in mind. I did not know existed. I literally thought it was a large boa, a python, or perhaps a small anaconda of some kind. My first thought was that somebody had a pet that somehow wandered into the boonies. God knows how, but somehow did, and I saw it. But no, I looked it up. They have some really, really large indigenous snakes, rattlesnakes here in Tennessee I didn't know about. That's pretty cool too. Good thing I saw those colors though. Good thing those photons reflected back and I saw the stripes on that snake. Otherwise, I could have been bitten by it. That would have been a very different reality to create. I'm glad I didn't do that one. All right, you guys have a good one. I'm about done. Bye.